Hello and welcome to this video. Today we will solve the Leetcode problem to find the step-by-step directions from one node in a binary tree to another. So here's the problem statement. You are given the root of a binary tree with n nodes. Each node is uniquely assigned a value from 1 to n. You are also given an integer start value representing the value of the start node s and a different destination value representing the value of the destination node t. Find the shortest path starting from the node S and ending at node t. Generate step-by-step directions of such path as a string consisting of only the uppercase letters L, R, and U. Each letter indicates a specific direction. L stands for left, R for right, and U means to go from a node to its parent node. So return the step-by-step directions of the shortest path from the node S to node T. So let's look at this example which you can see on the screen. So in this example we have a binary tree and we've been asked to find the shortest path from the node 3 to the node 6, and the expected output is UURL. So what does this mean? So if you start from the node 3, you go up, you reach node 1, you go up again, you reach node 5. Then if you go right, you need to get to node 2 to get node 6. So that is left after that. So that's why it is U, U, R, and L. So that is the shortest path to get from node 3 to node 6. Right, so let's look at the next one. Here it's just a small tree with just 2 nodes, and we've been asked to start from 2 and go to 1. So that is just left. So to solve this, firstly get the path from the root node to the start node. Then we can get the path from the root node to the destination node. Once we do that, then we need to identify the lowest common ancestor to these 2 nodes and consider only the path from that node and remove any paths we've used to get to the ancestor. So what does this mean? So in this case, since 5 is the node which we need to get to 3 and 6, 5 is the least common ancestor. So here's a test case which I have written out, and you can see the graph is starting at element 1, and this is the structure of the graph. And let's say I wanted to go from the node 6 to node 7, so I need to find the directions. Firstly, we need to understand the path from the root node. But first we'll get the steps from the root node till the node 6, so that is left, left, and then left again. Then we'll get the steps from the root node to node 7, that is left, right, and then left. And then we will find that element which is the lowest common ancestor. So in this case it is 2. So anything above 2, you don't need to worry about it. So we'll start with 6, and then we'll go up, and then up, and then we'll reach 2, and then we'll go right, and then we'll go left. So in this case it will be U, U, R, L again. The idea is we will first find the path from node 2 to node 6, then we'll find the path from node 2 to node 7. Once we've got these 2 paths, then each path letter in the first root will be replaced with the letters U, so it will be up, and then we'll append right and left, and that would give us the output required for this problem. So in the first step, we will try and find the node from the root node. So let's say we want to get to node 3. For that, we need to find the node 3. Then we want to get the node 6. Firstly, we need to find the node 6, and then we can build the path. So let's do that as the first step. I'm going to add a function which will let me get to a specific node. So I'm going to go with traversal to get to the nodes. For example, I'll first visit node 5, then I will go into node 1 and then recursively call the method which will then pass in node 1 as the start node, and that method will then go in the left and the right, and I will keep on calling the method till I find the node I'm looking for. So I need to write a method which will return a boolean, and it will look at the root node's value. If it's not matching, then it will recursively call this method on the left subtree till it finds the value we need. Then it will recursively call the method on the right subtree. So I'm going to write out the method now. Let's call it find path to value. And what we'll do is, firstly, we'll check if the value matches the root element. Go to value. So that means we have found our element. If not, then we'll continue traversing the left subtree and then right subtree. But before we call the method, we need to check that the left subtree is not null. So this time we'll pass it to the left because we want to traverse the left subtree and pass it the value we are looking for. And if that returns true, means we found the node. Similarly, we'll look in the right subtree. Otherwise, it's not present. Right, so that's our method, and let's call this method, and we'll call it on both the start value and the destination value. It's currently only traversing, it's not doing anything, but we'll add some print statements and we'll see what we get. So let's just focus on the start value for now. Alright, so let's see what happens when we get to the root node. We'll return true. So let's add a log just to see what we get. And if we didn't find it, let's just see where we reached. So this will log which node we visited. And let's try running this. Okay, we need to return some string where the compiler will not like it. Okay, let's just return empty and then we'll fix the code. I just want to show you the path that we're taking. So let's say in this tree example we want to get from 6 to 7. Okay, so if you look at the output std out here, you can see that to get to 6, which is the start value, it visited 1, 2, 4, and then it found the search node. So it went from 1, 2, 4, and 6. So 1, 2, 4, and then it found the search node. So that's pretty good. That means we found a way to get to the node we are looking to get to, and then we can slowly build the steps. So let's go back in the code and let's close that. All right, let's go back in the code and do the same for the destination node. Okay, so let's quickly run it again. So if you look at the tree visualizer, to get to 7, the path should be 1, 2, 5, and 7. Let's see if that's showing up correctly. Okay, so if you see here, it's gone from 1, 2, 4, 6, and 5. So it's visited Treetraversal, it's visited multiple nodes. So let's just copy this. Okay, and let's just go back in our test case and just see what we are getting, and that matches. Okay, all right. So it's visited 1, and then it's visited 2, yeah, and then it's visited 4, which is fine, and then 6, and then it has exited out of that because it couldn't find anything. So it's gone back to 5, and then it's found the search node. So that means our logic so far is good. It is working. We need to make sure that when we find something, we can store the steps. So that's the next thing we will do. So to get the steps, we need to store the steps in some sort of like a data structure. I'm going to use a list here, and then we can store the steps in this list. So what we can do is, when we don't find the matching, and we need to then go into the left subtree, and if you do find it, then we need to store an L in it before we return true. Similarly, if we have to then traverse the right subtree, we store an R in this list, and then we return true. Otherwise, we don't store anything. So that's the idea. Let's clean up some of the log statements. Let's remove this one. So to store the steps, I'm going to add a new parameter, and it will be a list of characters. Okay, and we'll simply store the steps. So I'm going to maximize this window. So I've got the list parameter here. We'll initialize it before we call this method, but for now, let's look at this, how we can add values in this. If we are traversing the left subtree, and then we can say and in the case of right subtree, okay, so that should give us the steps for traversing. So now we need to pass in the steps. I'm going to use linked list. We can print these values. let's just print this and see what it looks like. So let's go back to the, yeah, okay, let's clean up some of this. Okay, so we need to fix this compiler error because I forgot to pass in steps, and same thing here. Okay, let's run it now. Okay, so here's our output. So here, steps to get to 6 are LLL, that is left, left, and left. I think that's correct because if you look at the graph, it is left, left, and then left, and that's also looking good. Well, you can see what it looks like. Okay, so steps to get to 7 are LRL, so that is LRL. Okay, so let's try an example from the test case which we have got here. So I'm going to use this test case from this figure. Okay, so steps to get to 3 are L and L, correct? And steps to get to 6 are, it says L and R, so that looks a bit weird. And the reason for that is because we are doing pre-order traversal and we are recursively calling the method. It's only when we find the node is when we log the step. So what that means is when we go from 5 to 2, we haven't found the node yet. So then we go to 2 to 6, that's when we find the node, and then we say left, that's why there's L first, and then that method call finishes, goes to the upper call, and that's when it logs the path from 5 to 2. So that's why we have L and R. So at some point we'll have to reverse this string, otherwise it will all go wrong. So that's fine, it's not a big problem. So now that we have got the steps correctly, we need to find the lowest common ancestor between these two paths. So the next thing is to find the lowest common ancestor and discard any path which is used to get to the lowest common ancestor. So we'll just take the paths from the lowest common ancestor to the start node and the lowest common ancestor to the destination value. We need to remove the path from the root node till the lowest common ancestor. So because we're using recursive approach, the path to the node, the step to the node is at the end of the list. That means you need to remove the common steps from the end of the list. One thing we have a problem is because I'm using list interface that doesn't provide me with the reverse iterator. So I'm just going to switch this to linked list, and same for this one. Then I can get the reverse iterator. So the reason I'm getting the reverse iterator is because I'm going to be removing the elements or the common elements between these two lists from the end of the list. So let's first get the character or the element from the first list. And then from the other list as well. And if they're the same, that means we are still in the path from the root node to the common ancestor. Calling remove on the iterator removes the element it is pointing to. So in this case, it's going to remove this character. Similarly, it will remove the last element from the list of steps to the destination value. We also need to make sure that we don't delete any more nodes, so we'll break if they don't match. So in this case, we already are on the, if you look at this example, in both the paths, we'll have the steps to get from 1 to 2, and again from 1 to 2 for both the start node and the destination node. We don't want to use that. That won't be the shortest path. So we need to get rid of that step from getting from 1 to 2 from both the paths. That's what we're doing here. So we are iterating from reverse because we have stored the values in reverse, and then we'll just remove the elements from the end. Now that we have removed the path to get to the lowest common ancestor from the root node from both the steps lists, we can replace all the values in the first list. So, getting from 5 to 1 and then to 3 is L and L, we can replace them with U. So we'll do that. And we pass in a lambda, so which says for every character replace with U. And then we also need to reverse the second list. Once we do that, we can then combine all the steps by joining the lists together. Now all the steps are inside of the steps to start list. And now I'll simply build a string and return it. And for each character, we'll just say string builder.append the character, and we'll return string builder.toString, and that should be good. You can check. Okay, let's fix this problem. Okay, let's just call it destination steps iterator. Okay. Let's also run our custom test case and see if it works. Alright, so to get from 6 to 7, it has returned up, up, and right and left. That looks correct. Alright, so let's just clean up the code, remove these print statements, and that will be all. And run again. Okay, so I have completed this. I'm going to submit and we'll see if it's accepted. And thank you very much for watching. If you like this video, please consider liking and subscribing, and see you in the next video.